Hi, this is Dr. Green. We're working on WebAssign Homework 8 and problem number 6. So in this example, we're going to make some ice cream. I think in your homework example, they have you making beer, okay? But I'm in the mood for some ice cream. So we've got three kinds of premium ice cream that we make. Some dark chocolate raspberry, that's one of my wife's favorites. Moose Tracks, that's one of my favorites. And mint chocolate chip, which is also one of her favorites. You know, she's the queen of chocolate, so she rules. So of its premium ice cream, they usually produce 30% of the dark chocolate raspberry and 30% of the Moose Tracks, and 40% of what they produce is the mint chocolate chip. So I'm using those abbreviations. But they did a marketing test recently, and they took a sample of consumers, small sample, and 32 of them preferred the dark chocolate raspberry, 40 preferred the Moose Tracks, and 38 the mint chocolate chip. So they want to use a chi-squared goodness of fit test here, and they want to see if they should retain or reject the null hypothesis, which is going to be, should they keep the proportion of the dark chocolate raspberry at 30% and the Moose Tracks at 30 and the mint chocolate chip at 40, or are these observed frequencies, the 32 and the 40 and the 38, are they different enough that we should say, hey, we should change these proportions? So this one we're going to go ahead and we're going to carry the test out by hand, and then we're going to look at it in SPSS also, so that you get an example of doing it by hand. So our null hypothesis here is that the proportions follow this distribution. Our alternative hypothesis is going to be that at least one of those proportions is not correct. And then what we want to do next is we want to compute our test statistic, the chi-squared statistic, and the formula for the chi-squared statistic, that is on your formula sheet. Let's take a look at that. And that is right here. Okay, right here, our test statistic, chi-squared test. And it's the sum of the observed frequency minus the expected frequency squared over the expected frequency. And your expected frequencies you get from taking that total sample size times the hypothesized probability for whichever category you're looking at. And then you want to see if your test statistic is greater than the critical value, which we, for us, alpha is 0.05, where your degrees of freedom are k-1. So this formula right here, we want to figure that guy out. So here I came back to the problem, and I went ahead and put our test statistic down here that we're trying to figure the value for. Your WebAssign leaves off the subscript test is just chi-squared. So here's how we're going to do this. We list our observed frequencies. So that was the 32, the 40, and the 38, here, here, and here. So that was for the three categories. This is the Dutch chocolate raspberry and our Moose Tracks, and then down on the bottom our mint chocolate chip. And then to get the next step, we're going to figure these guys here, the expected frequency. So to get the expected frequency, our total sample size here, N, capital N, is equal to, we surveyed 32 people that liked the raspberry, and then there were 40 more that liked the Moose Tracks, and then there were 38 more that liked the mint chocolate chip, and that's a total of 110. So that's our total sample size. So if we're expecting that 30% of those are going to prefer the Dutch chocolate raspberry, then our expected count is going to be 110 times 0.3. We expect 30% of the 110 are going to like the Dutch chocolate raspberry, and that's 33. And then we do the same for the other two. So the second probability or second proportion was 30% for the Moose Track, so 110 times 30%, 33, and then it was 40% here for the mint chocolate chip, so 110 times 40% is 44. And if you add all these guys up, they add up to 110 there on the bottom. So that bottom row is our sum. Okay, next we're going to subtract first column minus second column. So observed frequency minus expected. So we do 32 minus 33 is -1. 40 minus 33 is 7. 38 minus 44 here is -6. Next column, we take the difference in the observed expected, we square it. Okay, so we take this column and we square all those numbers. So -1 squared, you square a negative, you get a positive. So that's +1. 7 squared is 49, and then the -6 squared here is 36. And then, before we add everything up, we've got to divide those squares. So right now we figured all of these numerators and divide all those things by the expected frequency. So I want to take this value here, which is the top number right there, and I want to divide that by the expected frequency, which is 33. And if you round that to 2 decimal places on the calculator, that's 0.03. So actually to 3 decimal places, it's 0.30. And then do the same for the others. So take the 49, divide it by the expected column 33, 49 divided by 33, 1.485, and then 36 divide by 44, the expected column 0.818. So that's all these values. And then we total them up here. So I added these three values up, got 2.333. Well, that's what this is. This is the sum. Remember that sigma there means sum or total all of these values. So this table method is a nice way to do chi-squared by hand. So our chi-squared is going to be 2.33. And they wanted to 2 decimal places here. And now we want to decide, are we going to accept or reject the null hypothesis? So we need to find our critical value here. And to do that, we need our degrees of freedom, which is defined to be k minus 1. K is the number of categories that you have, which for us is 3. So 3 minus 1 is 2. So we want to find chi-squared with 2 degrees of freedom for 0.05. Turns out to be 5.99. Let me show you where that is. That's in the table in the back of the book. Again here, if we go back to, let's see. Oh, I didn't mention the table. I thought I put the page number down for the table, and I didn't. So that is actually table B.7 on page 669 here. And we have 2 degrees of freedom, and we're looking at 0.05, so 5.99 right there. Okay, so that's this 5.99 is, that is table B7, and that's page 669. And then what we see here is if we compare these two, you're going to reject, remember here, if you do this by hand, you reject, your rejection region is if your test statistic is bigger than your critical value. Okay, well, here's our test statistic, 2.33, and it's less than, it's not bigger than 5.99. Our 2.33 here is less than 5.99. So we are not going to reject, we're going to retain the null hypothesis. So that's doing it by hand. So it takes a little bit of work, and that's just a small problem. You know, if we had a bigger problem, it'd be a lot more work. So we want to bring in SPSS and help us out here if we can. So here are the SPSS steps. So let me take you through, I've already got the data prepared, but let me show you how to prepare the data and then take you through the steps here. Very similar to what we just did up above. All right, so here is our chi-squared data. So we've got our dark chocolate raspberry here, our moose tracks, and our mint chocolate chip. So that's a categorical variable of ice cream. And then we have our counts here, the 32, 40, and the 36. So just like before, we have to go to the data menu and then come all the way down off the bottom of the screen, very last option, weight cases by, and then here the variable's already over there, but usually it'd be on the left hand side here, and the do not weight cases would be clicked. But we want to do weight cases by and then bring our count variable over. This is the count for problem 6. Click OK. And then once you do that, you want to go to Analyze, and then we're doing non-parametric tests, and then one sample. And then check on the Fields tab, and bring your grouping variable over, which for us is ice cream, not sport any longer. Let's get rid of that. That was the last time. And then we're going to go to the Settings tab. It's already clicked from the previous problem, but the default is automatic, you want to click Customize. So this is our default. You want to click Customize Tests, then click Compare Observed, so that's chi-squared, and then click Options. And here we had previous information in there from the problem on sports, so we want to change this information. Let's go ahead and just go ahead and delete here. And so we had Dutch chocolate raspberry, or dark chocolate raspberry, DCR. And then we had the moose tracks, MT. And then we had the mint chocolate chip, MCC. And then our proportions were, go back to a problem real quick here. Let's see, our proportions here were 0.3, 0.3, 0.4. So 0.3, enter, 0.4, or I'm sorry, 3 again, enter, 0.4. So 0.3, 0.3, 0.4. And then we click OK, and then we click Run. And here's our output. And so I went ahead and took our hypothesis test summary and brought that back over. So that is right here. And then I've also got the test value, because they asked us for the test value up here, the 2.33. And if you double click on this box, then it opens up another box for you here. And over here is just the summary. But over here on the other side, they show you how the expected and so they show you here how the observed and the hypothesized or expected counts line up for each brand of ice cream, or each type of ice cream, dark chocolate and the moose tracks and the mint chocolate chip. And they tell you at 110 total, and then there's our test statistic. So I went ahead and I brought this table over with the test statistic. So I just copied that and I went ahead and brought it back over to the problem, and that's right here. And notice that we see our test statistic 2.333, which is the same as what we got right there. So that's how you would do that, and then we are retaining the null hypothesis. And that's what we did up here. So this is what you would do in SPSS. A little bit less work than here.